Hello everyone, in this video we are going to see an example of data cleaning. Of course, one of the main agendas in this course is going to be covering a lot of data cleaning examples and techniques and concepts. Here what we will have is a very simple, very surface level data cleaning that is necessary for us to sort of like get going to get to deeper material. So let's look at this example, and this type of cleaning I call them level 1 cleaning, or at the surface level. We want to make sure that the data that we have has enough structure that can support our analytic purposes. So let's see this example. Okay, so the example that we are going to be working with is air quality data. This data comes from a location in city of London, and five different measurements of air quality has been captured every 15 minutes, and we have that data, and we want to clean this data at the level 1 cleaning to be able to look at different things about it in the videos that are going to come after this one. So the first thing we do, we are going to work with pandas data frame. So we import panda, and then we use that read CSV to read this data. And once we use df.head, we will see that there are different columns in this data. So we have the site where this data is collected, CT3. We have species, which is the type of measurement. It's NO, the first 5 we see. Then we have reading date time. Then we have that value, and then we have the unit of the species, and we have provisional to ratify. So this is the data we see, and of course, what we are seeing here is the first 5 rows. If we get all of them, we will see we have around 43,000 rows. And the reason we sort of like do this is because we don't want to like take up a lot of space in our screen. So we know the data is there, but we don't really want to do what we do in Excel to scroll down and see what's happening. We have better tools here. So let's see if all of these 6 columns are even necessary in this data set. So what we do normally to check out if that's the case, we make sure to know the possible values each of these columns may have. So we use the function .unique for each of these series, each of these panda series, df.site, df.species, df.reading date time, df.value, and df.uniques, and df provisional or ratified .unique. So once we run this, now we will see that the only one possible option for site is CT3. So this data is coming from the same site, and perhaps it's not necessary even to include this in our data. And then we see we have 1, 2, 3, 4, 5 different species, and we do want these information, so we keep this column, and we see that reading date time, it has a lot of different types of values, and that is big enough that it's been broken. So probably we'll need this column as well. The same thing happens with value. Of course, we expect to see many different variation here. And also we see there are a couple of different options for the units, but ratified or provisional, all of them are apparently ratified. So we can go ahead and drop site and ratify or provisional, because they're not adding any information to these columns. They're always the same. So to drop a column, you simply use the function drop in pandas data frame. So you say your data frame .drop, and you specify the columns in this way. You have to say columns equal brackets, and then you say these are the columns I want to drop. So once you run this, now you will see your data frame does not have those two columns. Let's, for just making sure, let's check it one more time, and we see that actually there is something happening here, that even though we think what we are having, we are dropping the columns, we are not dropping the columns, because once we say df, cite and provision ratifier are come back here. So again, if you remember in the previous video, we saw something similar to this. So what's happening here is that drop function is outputting this new data frame. And what we are seeing here is that output. It's not this data frame. So because of that, when we say, okay, now show me the data frame hasn't been affected, it hasn't been changed. So because of that, this is what's happening. So there are two ways to go about this. One way is to sort of like get that output and show that output instead of like just like showing the output and not saving anywhere. And this will give us the result. Or we could be using the function in place true. So once we do this, once we run this, now we are changing that data frame itself. And that does the trick for us. One of the things that is very important for data analytics to be able to work with are working with strings. So pandas luckily have a lot of good functions for us. So for example, here we want to sort of be able to sort of separate this information, reading date time. We want to like have the time, the day, the month, the year separate for our possible analysis. And because this has been stored as a string, we could be working with those very useful functions to sort of help with that. So one of the things that we could be using is use the function split. So here we basically say split all of the values in the reading date time column or series by space. So everywhere you see a space, where do we have a space between date and time? Everywhere you see space, split them. And that's what happens. So we will end up having two separate values, and that's what split is. So if I go ahead and put this as a series, this is what I will be getting. And this is, we can check that this is a series. But series in this way does not give us separate access to these values. If it was a data frame, we would have a much better access to these values. So the way you go about making sure that the output is going to be a data frame, you say expand true. What that means is, it means I want each of the result of the split to be stored in different columns, in different series, in a format of a data frame. So once I run this, now this is in a format of a data frame. So I can check, and this is a data frame. I could be changing the name of these columns very simply. I say df2 columns, I want them to be date and time, and now I will get that. And then next thing I want to do here is to show you how this can be useful. So for example, I want to separate all of the 1 AM data in my original data frame. So I use this Boolean mask. You see, I create that Boolean mask using the date time data frame. And it sort of like only keep those 1 AM data. If you compare these two, this is 0, 1, 2, 3, but these are only 1 AM data. And now I could also be using the same Boolean mask to filter out the original data. So this is the original data, and now I'm only looking at only the 1 AM. So you can see why we are going about this splitting and changing the structure of data. Now we can access our data using the Boolean mask at different levels by now having access to each time, each day, each month, each year. And the interesting thing here is that I created a Boolean mask using another data frame, but I'm using it for another data frame. And this is working well because, so think about the because of it. Just a second. Stop this video and think about the because of it before continue to watching this video. Because the rows of this data frame are the same as this data frame. So they have the exact same number of rows. Not only that, but also each row is presenting the same entity. Because of that, if you create a Boolean mask based on D8 time 2, which is a data frame, and use it for another data frame, which is our original data frame, it's just working for us. So that's how one way you could go about this. But perhaps it's even better to sort of join what we have as a date and time into our original data frame. And we can go about that by using join. So I could go ahead and say, I want to join date time 2 and drop the reading date time and create a new data frame. And I can see now I dropped this one, but I have date and time as new columns, and I'm only using join. Pay attention the way this function join work. It basically connects the information of the two data frame based on the indices. So wherever the indices of this DF has the same indices in daytime 2, it connects that information together. So that's the basis of how this function works. So let's see an example. We were able to separate the date and time, but how about taking one step further and also separating the day, month, and year, and sort of like split the state. So it's very similar to what we had, but with slight changes. First of all, we have to split on the slash instead of the space, because this slash is what's separating this information. And we know it's better to expand through, and then we know the columns are going to be day, month, and year. And then we go ahead and join that to our new data frame. And once we run this, now we see day, month, and year are also added here. Another useful function we could be using here is the function replace. You can see there are some non-necessary information or non-necessary character here. Because the time is from 0 to 23, these colons, these 0 after, these 0 before, are perhaps not necessary. So we could be replacing these items, these values. So the function you can be using is the function replace. It's basically saying everywhere you see this, I want it to be this. So once you run this, now the data frame or that series that comes from there you see is going to have 0 instead of every time you see 0, 0, colon, 0, 0. So to actually do this one by one, it would not be the smoothest way to go about this. Perhaps you can use a dictionary, replace dictionary, basically saying all of your replacements. So you say this is one replacement, this is another replacement. So all of the replacement you want, you sort of present them as a dictionary. Once you have this, now you can say replace and say it's for the column time and use this dictionary to do all of the replacement. Once you run this, and of course in place true, once you run this, and of course we're getting an error because I haven't gone ahead and run this chunk of code. So once I run this, I have this dictionary. Now I say I want to change time, or like replace the values in column time using this dictionary. So once I run this, now all of those values become 0, 1, 2, 3 to 23. And now I can work with these as integer, as numbers. And that's achievement for being able to work with these as numbers. So one thing that might seems counterintuitive is the fact that this is a programming environment. Why are we typing things away here? And of course there is options to, instead of typing these, to create them. And of course one of them is going to be using a for loop to create this instead of typing this out. Or Python has a concept, list comprehension, that can allow you to come up with these dictionaries, these lists, by just in one line. Basically, list comprehension is a for loop in one line. So let's see a couple of examples of them, and then once we understand what list comprehensions are, we will recreate this replace dictionary. So imagine we want to create a list with values from 1 to 20. All you need to write is this. So once you run this, you have created what we had here without having to type up everything. So the list comprehension works this way. So you have your bracket or parentheses or whatever it is that you want to create, and then you have a formula on a variable, on a thing, and this is for, and then this is the thing that you want to use in the formula, and this is the repetition or the collection of things that you have. So here if I want to do some calculation on these things, I could be saying I want 3, 6, 9, 12, which is the same thing as this list, but all of the values are multiplied by 3. All I need to do is to change the formula here. So once I run this, now I have that list that I had here. So list comprehensions are useful in a sense of making your code more compact and readable than having to create a loop, because I could be creating that dictionary that we just saw here on top here, but also sort of like an explicit loop function. So here we go, let's do that here. So I say I want to replace dictionary, and then I sort of like start using a for loop by adding values to this dictionary. So if the I is greater than 9, and the reason for that is because after I greater than 9, there is not a need for a 0 coming before that value. So if I is greater than 9, I want to sort of like create this format, and then instead of this %s, I want to put the string of this number, and then in front of it I want that string of that number. So for example, if I is 10, I want 10 to sit here and also 10 to sit here. And if I is smaller than 9, I want 1 0, let's say it's 5. I want 1 0 before that number, and then I want that number here. So once I run this, now I have that dictionary that it works for me. That just that's how that dictionary was. But I could have also done this with the list comprehension. So this is the list comprehension. And of course, for your list comprehension, it's a dictionary. And of course, you will have, the structure of the dictionary, which is, this type of bracket and also the colon in between. So here, for the first part, what you have is sort of like a for loop, but also it has an if in it. So you create your for loop. You say all of those values are going to come from 0 to 23. And then here, you only want those values. So you say, I want those values to be here. And also, once you have that before the column, if it's greater than 9, you don't want a 0 to be before this. If it's not greater than 1, you want a 0 to be before this. So once you run this, now you get the same values. So list comprehension, as useful as they are not essential for you to be able to do data analytics. If for any reason this went above your head, make sure that you do understand how to create this dictionary by an explicit loop. If you don't understand this list comprehension, it might take a few, take a while for you to be able to sort of like get the hang of what list comprehensions are. Perhaps, after doing a couple of data analytic projects, once you come back to it, it starts making more sense. So if you did not understand the list comprehension part, that's absolutely fine, as long as you do understand the explicit loop. Every time you need something like this, you need a list comprehension, you just go ahead and do the explicit loop until you become more comfortable with programming that this starts making sense as well. So let's go ahead and use that replace dictionary that we had and then create our new DFs, and that just worked the way we wanted. Another thing that we might want to do as far as level 1 data cleaning is reorder the columns. So the way you go about that, you basically say new DF, and then you introduce the new order of your columns as a list, and it just reorders the columns. And once you're done with cleaning your data, you could just save it as a new CSV. So here I am changing the name. I'm calling it clean because I don't want to save on top of the file that it was there. I say, okay, this is a cleaned version of that data. And normally I say I don't want the indexes to be a part of the data, because next time I read this in pandas, it's going to assign index for them. Because of that, I say index is equal to false. So once I run this, now whatever your Jupyter Notebook file is, now there's going to be a new file, a new CSV file, which is containing this new version of your data, which is